Math 155. This is part two of annuity in 9.3 of Math 155. So last time we talked about this particular formula where we can find the future value if we know what the monthly payment or periodic payment is, okay, in order to find the future value. Now, this formula we're going to do is backwards, okay, trying to figure out what will be our periodic payments, having a future value in mind. So the two formula is basically the same. We just they just um, do a little bit of algebra. That's the reason why all the components in the two formulas are exactly the same. All right. So the regular payment amount need to reach a future value goal, okay, is this formula here, where the FV is the future value that you want, like a set amount of money you want to retire with. R is your APR. N is a number of the regular payments made each year for T years. All right, so very much the same as this formula, okay, except we trying to find the payment now instead of a future value. So let's say, suppose you like to save enough money to pay cash for your next car. Okay, we talked about car payment before. The goal is to save an extra $21,000 over the next 6 years. Okay, what amount must be deposited quarterly? Okay, ooh, right here, quarterly. So quarterly simply means my N is gonna be 4. So that means I'm making payment into this particular account 4 times in a year, earn at 5.6% interest in order to reach your goal. All right. So what's my quarterly payment? That's what this question is asking for. So my payments is equal to the future value I'm desiring, 21,000 times, all right, R over N. That will be 0.056 divided by 4. I'm making quarterly payments. Whole thing divided by, okay, bracket, parenthesis, 1 plus 0.056, right? R over N again, close parenthesis, raised into the N times T power. N is 4 times T is 6 years. Then make sure we minus 1, okay, and close the bracket. So again, what I'm going to do is figure out this big old fraction first in the calculator. All right, then I will times by my $21,000. All right, let's see how we put it in. So the numerator, open up with a parenthesis, 0.056 divided by 4, close it, divided by, all right, let's open the bracket. Now open the inside parenthesis here, and then have my 1 plus 0.056 divided by 4, close parenthesis. All right, exponent, I'm going to open my blue parenthesis here for the exponent like I did before. There you go. So the 4 times 6, all right, close the blue parenthesis, minus 1, then close the bracket. Okay. All right, so that will be 0.035 something. Now times the $21,000. There we go. My answer, $742.27. So this is a quarterly payment. All right. right, so just imagine divide that by on quarterly payment means every 3 months of the year. So if you divide it by three, that tells you the monthly payment is about $247. Okay. You don't have to know that. I'm just kind of do a comparison. If you're thinking about buying a car that is $21,000, okay, rather than pay the finance charge, okay. When you make a payment, you're paying towards the principal and the finance charge to the lender. Instead of that, why not save the money ahead of time and then pay cash for the car? Okay. But most of the time when people buying cars, their first instinct is, 6 years later, that same car is no longer the same. So that's the reason why whatever the car people want today, they want to buy it right away. Very rarely people save up a large sum amount of money to buy a brand new car. Okay, very rare happens, but that's the reason why, believe it or not, a lot of people like to buy reliable used car. Okay, where they can keep on, where they can save a little bit of money, buy a good used car, and then while they drive that car, keep on saving more money for it for the next one. Okay, so that's a good way to go to be, to keep yourself out of the debt. All right, let's take a look at a different one here. This one is Celine wished to retire at age 67 with $1.1 million in her retirement account. When she turned 22, she decided to begin deposit money into an account with an APR of 7%. What is the monthly deposit? All right, so this is a monthly deposit, okay? So what that means is my N is going to be 12. She's going to make monthly deposit. All right, so what is the monthly deposit that Celine must make in order to reach her goal? All right, so she's begin at age 22 and she wants to retire at 67. So the time she's going to do this, 67 minus 22, so that will be 45 years. So she's going to do this for the next 45 years and make payment into this particular account at 7%. Okay, 12 times a year for 45 years. All right, so we got our future value in mind. Now we need to figure out what our payment is. It's a good estimation. So take 1.1 million times. All right, let's follow the formula, okay? R over N, that will be 0.07 over 12 divided by, all right, the bottom is pretty big, started with a bracket, parenthesis, 1 plus, R is 0.07 divided by N is 12, raising to the 12 times T, 45 years. Make sure we minus 1, close bracket. All right, so I'm going to put my 12 times 45 in the blue parenthesis. Okay, let the calculator figure that out for me. All right, so let's take a look. She needs to end up with $1.1 million after 45 years. Now, let's put this big old fraction in the calculator first, then we'll times by 1.1 million. So parenthesis 0.07 divided by 12 divided by, all right, divided by, open the parenthesis for the brackets, open another parenthesis that's inside, 1 plus 0.07 divided by 12, close parenthesis, okay, for the 1 plus something, exponent, open the blue parenthesis, 12 times 45, close the blue parenthesis, then minus 1. And then make sure we close the bracket. All right, so here it is. This is a scientific notation. This means 2.6 times 10 to the negative 4 power. All right, it's all right. We need to times by 1.1 million. That's 1,100. $1,100,000. 1, 2, 3. Voila. Her monthly payment is going to be $290.04. So think about it though. If this is her monthly payment, right? If this is going to be her monthly payment for the next 45 years, so if I take 290.04 times 12 months in a year times the next 45 years, so that means she will only put in $156,000. But this account over the years, because the compound interest will earn her $1.1 million. Okay, that's a good trade-off if our rates can stay at what? Can stay at 7%. So what happens if we are half wrong with this? Well, if we are half wrong, that means she will just earn a little bit less than $1.1 million. Okay, so pretty interesting problem. Okay. So, I mentioned this before. Opportunity cost, money spent paying in your monthly payment for your car payment, for your TV payment. Okay, any sort of debt cannot be used. Those same amount of money cannot be used to actually put into your retirement. Okay, investing for your future. It's called the opportunity cost. Money go one place, cannot go another place. All right. The next two example is about gems. Okay, this is the two problem is slightly different. So I'm going to show you how to do this real quick. So let's say gems deposit $768 each quarter into annuity account. So right now we know every 3 months or 4 times a year he is putting money, making a payment into his child's college fund. He wishes to accumulate a future value of $65,000 in 16 years. Assuming the APR is at 3.4%, how much of the $65,000 will James ultimately deposit? So the question is asking, if he deposited the 768, ultimately, how much of that $65,000 that he won he will actually deposit? Just like what I did with the $290. $290 a month times 12 months a year times 45 years. Ultimately, Celine will only put in $156,000. So now, with this same problem, same concept with James, how much will he ultimately pay in 16 years? So this is $768.51, right? Times, well, he's not making this. Okay, he's not making this. He's actually not making this monthly. He's making this by the quarter. Okay, quarter means 4 times in a year. So 4 times in a year times the next 16 years. Okay, so this 4 means quarterly. Earlier, when I typed in a 12 for Celine, that's 12 months in a year. All right, so if you put in the calculator, times 4 times 16, so he will only end up paying $49,000 or so. 491, what's that? Good tapping, all right. 4918. 4918 4.64. All right. So he will actually deposit. So that goes in the first box, $49,184.64. And how much is interest earned? So the interest earned. So inside this Okay, inside this $65,000, it has the money he put in and the interest he earned. So to extract the interest, we will take the $65,000 minus what he put in. All right, so if I subtract, so the interest earned is 15,815.36 cents. Okay, so that will be the interest earned. All right, now same kind of problem. Okay, if you read this problem, it's just like the top, except, okay, at the beginning it says James deposit a fixed quarterly amount. It doesn't tell me what it is. All right, he wished to accumulate the value to $60,000 in 12 years, assuming an APR of 3.3%. How much of the $60,000 will James ultimately deposit? So the difference between the two problems is up here it tells me what the quarterly payment is. Down here it's just saying a fixed quarterly amount. So what that means is I need to find what this quarterly payment is first. So this particular problem, we will need to use this formula first to find out our payment, quarterly payment. Then we will go through the same steps, like the previous problem. All right, so let's find our quarterly payment. We got to have that regular payment first in order for us to times by 4 times a year times so many years. Alrighty, so our payment will be, ultimately the future value we want is 60,000. So I'm just looking at that formula above me. R over N. R is 3.3%, which is 0.033 over N, quarterly amount, quarterly. So my N will be 4. Divided by brackets, parenthesis, 1 plus 0.033 over 4. Whole thing raised into the N is 4 times T. How many years am I doing this? 12 years. Minus 1. Alrighty. So let's see what's our monthly payment. I will write it down here. This is the last problem. I'll move it down a little bit. Alright, let's type in what's inside this big old fraction first, okay? Parenthesis 0.033 divided by 4 divided by, open the parenthesis for the bracket, okay? And then we open the parenthesis for the inside, then do my 1 plus 0.033 divided by 4, close parenthesis, raising exponent, put my exponent in a blue parenthesis here. So open blue parenthesis, 4 times 12, close the blue parenthesis, the minus 1. All right, let's close the brackets. Okay, all that times by the $60,000. Here we go. So the monthly payment, the quarterly payment, excuse me, is $1,023.88. All right, so that's my quarterly payment. So the question asking, ultimately, James will deposit so much. How much money will James ultimately deposit? So this is $1,023.88 every quarter. Quarter is 4 times in a year, and I'm going to do this for the next 12 years. So that will tell me how much money I deposit. So to get the interest out of it, Okay, the second part is finding interest. We take the $60,000 and minus whatever James put in. So 1023.88 times 4 times a year times 12 years. So that's 49,146 point 24. 49,146.24. All right, let's subtract that from 60,000 so we know how much interest. So James put in deposit $49,000. So the interest earned from the account $10,853.76. All right, so that's how we do this problem. So the two examples are pretty much the same. One of them tell me what my quarterly payment is. So if it does not tell me, then I need to use the payment formula. PMT, sorry. I need to use a payment formula to find the quarterly payment or monthly payment before I can find out how much James will deposit and how much interest earned from the account. Alrighty, let's try two more. Juleta and Eric are purchasing a home. They wish to save money for 10 years and purchase a house that has a value of $150 with cash. All right. Paying cash for house. If they deposit money into an account paying 7% interest, how much do they need to deposit each month in order to make that purchase? So let's see. Their payment into this account every month will be the future value, what they're trying to save up for, $150,000 times R is 7% is 0.07 divided by how much they want to deposit each month. All right, so I'm making 12 payments a year, so divided by N is 12. Divided by brackets, parenthesis, 1 plus 0.07 over 12. Whole thing raising to the N times T, 12 times 10, then minus 1. Alrighty, let's see how much they will need to deposit into this account. So open parenthesis, 0.07 divided by 12 divided by, open the bracket, open the parenthesis that's inside in the bottom. Okay, bracket parenthesis after division, 1 plus 0.07 divided by 12, close it, exponent. Now let's put my exponent, 12 times 10 in the parenthesis. So I'm going to open my blue parenthesis, 12 times 10. Close the blue parenthesis, minus 1, and then make sure we close the brackets. Then, what did I type in wrong? Oh, right there. I forgot to put 1 plus right here. Well, insert 1 plus. There you go. Wrong spot. There you go. All right, times by $150,000. There you go. Their monthly payment, $866. $866.63. Alrighty, so that's how much money they will need to save monthly. Alright, last one. Suppose you wish to retire at age 65 with $80,000 in your saving. Determine your monthly payment into an IRA. If the APR is 7.5% and you begin to make the payment at 20 years old. By the way, it's never too late to save money. Colonel Sanders was way into his 60s before he even fried any KFC chicken commercially. Okay, so there's a lot of example where people actually do better at later on their age. Okay, so never too late for anything. So we're going to begin this at 20 years of age, retire at 65. So that's 65 minus 20, which will be 45 years again. All right, so let's see how much we need to determine our monthly payment. All right, so my monthly payment, I want 80 grand in my account times R is 0.075 over N monthly, right? Very good. Whole thing divided by bracket parenthesis 1 plus 0.075 divided by 12, raising to the, I'm gonna go ahead and open my blue parenthesis, okay? All right, 12 times in a year, making this payment for the next 45 years, minus 1. All right, so let's see. Open parenthesis, 0.075 divided by 12, close parenthesis, then divide, open bracket, open parenthesis, 1 plus 0.075 divided by 12, close it, exponent, open blue parenthesis, 12 times 45 times that right here, minus 1, close bracket. All right, times that by 80,000. So monthly payment, just $17.91. Okay. So in this lecture video, we talk about these two big formula: finding the future value. Okay, annuity formula for finding the future value. All right, knowing how much is my periodic payments. Okay, if I know my interest rate and how many times and what my compounding period or how often I'm gonna deposit this money, then I can find my future value. And vice versa, if I know my future value, if I set a goal, what we want to save money up for or retire with, then we can actually use the same formula, just slightly, use it slightly differently. Then we can actually find our payments, okay, either it's every month or every quarter. Okay, so we know how much money we need to deposit into these accounts, okay, periodically. All right, so that will conclude this lecture video on annuity. Thank you for watching.